Introduction. While cooking food, if you leave the metal stirrer in the cooking utensil, you feel it hot when you touch it after some time. Why does this happen? You were not heating the stirrer, but still it became hot. How? Let us find out in this lesson. Objectives. At the end of this lesson, you'll be able to explain effects of heat, identify modes of heat transmission, conduction, convection, and radiation. Explain good and bad conductors of heat. When an object is heated, it undergoes many changes. The object becomes hotter. The object may expand or contract in size. A substance may change its state when heated. For example, water changes into water vapor on heating. We observe a change in temperature on heating. On heating, temperature rises, and on cooling, the temperature comes down. In nature, the sun energy brings about a change in temperature. The days are warm, while the nights are cool. Summer is hot, winter is cold. Matter exists as solid, liquid, and gas. All the three states of matter expand on heating. The expansion of matter depends on the temperature through which it is heated. In this case, when we heat this plate, the higher the temperature, more is the expansion. Expansion of matter also depends on the size of the material being heated. The longer the plate or bigger the bowl, more is the expansion for the same rise in temperature. The nature of the material being heated also plays an important role in expansion. For example, copper expands more than iron for the same rise in temperature. Liquids and gases are fluids. They expand on heating. Expansion in gas is very large as compared to solids or liquids. Let us look at some practical uses of thermal expansion of solids in daily life. The iron rim is fitted in bullock cart wooden wheels by heating. When the metal cools, it holds the segments of the wooden wheel firmly. A small gap is left between the rails of a railway track, where the two rails are joined with the help of a fish plate. The gap is left to allow space for the expansion of rails in summer. Let us now look how heat affects the change in state. On heating, a solid changes to liquid and a liquid changes to gas. Conversely, on cooling, gas loses heat to change into a liquid and a liquid loses heat to change into a solid. The temperature at which a solid melts to change into its liquid form is known as its melting point. Melting point of ice is 0 degrees Celsius. The temperature at which a liquid starts boiling and changing into its gas state is known as its boiling point. Boiling point of water is 100 degrees Celsius. Perhaps you have observed that when a stove is lighted in the kitchen, the air inside the room becomes little warmer. If this air is allowed to come out through an open window, it gradually cools down. The metal stirrer left in the cooking bowl becomes hot. These examples indicate that the bodies at higher temperature lose heat and consequently their temperature falls. When bodies gain heat, their temperature rises. There is a mutual exchange of heat between bodies at different temperatures. Flow of heat takes place in a particular direction, that is, from bodies at higher temperature to bodies at a lower temperature as water flows from a higher to a lower level. There are three modes of transfer of heat from one place to the other place. These are conduction, convection, and radiation. Let us perform an experiment. Take a metal rod, hold one end and heat the other end. In the beginning, the end of the rod in the hand is not hot. However, very soon we find that the end becomes hot and we are not able to hold the rod any longer. It means that some heat has been transferred. The process by means of which heat is transferred in a solid body from one part to the other is known as conduction. Conduction happens mainly in solid. Note that conduction is not possible in vacuum. Remember that there are two important conditions for heat to be conducted from one body to another. These are: the two objects should be in contact and their temperatures should be different. The process by which heat is transmitted through a substance from one point to another due to the actual bodily movement of the heated particles of the substance is called convection. Convection of heat takes place in fluids, that is, liquids and gases, and involves the movement of matter from hot regions to cooler regions. In convection, heat is carried by moving gases like air and by moving liquids like water. A movement of air which carries heat from a warmer place to a cooler place is called convection current. There is a third way by which heat can be transferred from a hot body to a cooler one. This mode of transfer is called radiation, and it does not need any medium between the two bodies. All hot bodies radiate heat. The hot objects radiate heat rays to the surroundings. Heat from the sun comes to us by radiation. It travels through millions of kilometers of space to reach the earth. When this heat falls on some object, a part of it is reflected, a part is absorbed, and a part may be transmitted. The temperature of the object increases due to the absorbed part of the heat. A cloudy night is hotter than a clear night. When the sky is clear, the heat radiation goes into the atmosphere, but due to the presence of clouds in the sky, these thermal radiations are reflected back to the earth and one feels warmer. Breeze is caused due to difference in heating. Let us see the cause for land breeze and sea breeze. During the day, land gets heated more than the sea water. Hot air above the land rises up, and therefore the cold air from the seaside moves towards the beach. This is sea breeze. At night it is exactly the reverse. The water cools down more slowly than the land, so the cool air from the land moves towards the sea. This is called the land breeze. Summary. Let us summarize what we have learned. There are three ways in which heat can flow from one body to another. These are conduction, convection, and radiation. In solids, generally the heat is transferred by conduction. In liquids and gases, the heat is transferred by convection. No medium is required for transfer of heat by radiation.